Hello, everyone, and welcome to our Facebook Live discussion, Electric Vehicles, Implications and Considerations for Emergency Responders, brought to you by the National Volunteer Fire Council and supported by General Motors. We are recording today's session. I'm your host, Trina Wafle. I'm the Assistant Director for Program Development and Research Services at the West Virginia University Energy Institute, and I also serve as the Interim Director of the National Alternative Fuels Training Consortium. NAFTC was launched in the early 1990s by WVU and several community and technical colleges to embrace all alternative fuels and cleaner forms of transportation. We recognize the important role that our first responder community plays in this transportation revolution we're all experiencing. And so I'm very happy to be joined today by subject matter experts in the field who will introduce themselves momentarily. Electric vehicles, or EVs, as you know, are becoming more and more common, and the likelihood that volunteer departments will respond to an incident involving an EV increases daily. It's important to be prepared for these incidents, as the implications for emergency responders are different from those of conventional internal combustion engines. Before we jump into today's discussion, I'd like to take a few minutes for introductions, and I'll start first with Tom Miller. Tom, would you say hello and introduce yourself?
Good afternoon, everyone. Thank you very much for joining us. My name is Tom Miller. I'm the West Virginia Director to the National Volunteer Fire Council. I am a Pro Board Certified Fire Instructor 3 with West Virginia University Fire Service Extension, and I serve as a voting principal on the NFPA 470 Technical Committee, which deals with the response to hazardous materials and weapons of mass destruction.
Thanks, Tom. And Sam, I'll turn it over to you.
Well, thank you, Trina and Tom. It's nice to be with all of you. So I'm Sam Spofforth, and I'm a project leader of the Clean Cities project leader with the National Renewable Energy Laboratory. But I spent the last 20 years running Clean Fuels Ohio, which is one of 75 designated so-called Clean Cities coalitions through an initiative operated out of the Department of Energy. And I'll say more about Clean Cities a little bit later, but just to be clear, it's a program focused on transportation, sustainability, equity, and advanced technologies. And it is not about cities, it is about all communities. And so we're active in all communities around the country.
Thanks, Sam. Thanks, Tom. Thank you for both being here. And today's discussion will last about an hour, depending on how many questions we receive. Now, those of you in the audience can send questions via comments in Facebook or in the chat feature on Zoom. And I have some questions in front of me already to start the discussion. So whenever you've got questions, feel free to ask them and we'll get to those, and we'll get started with the few that I have here. So the first question I'd like to do is to try and set the stage for what we're seeing with electric vehicles in particular. You know, the popularity of EVs has increased in recent years, and many volunteer departments are in smaller communities where they might not be quite as common. What do you say to those who might not feel the topic of today's discussion is necessarily pertinent to them in their location and their department? And I am myself, I'm from a very rural state, so I understand where this question is coming from. Sam, because you have a nice view of the nation, perhaps you can take this on.
Well, sure. Happy to, Trina. Well, I guess, first of all, you know, we've really seen a lot of growth in the availability of various electric vehicle models in recent years. We're now up to 83 different light duty models as of 2020. So that was even a couple of years ago. We have several new pickup truck models coming on to the market in 2022. I think, you know, a lot of people have seen the advertising for the Ford F-150 Lightning. There's some other pickups that are coming on the market, some SUVs that will be coming as well. And there's even, you know, a number of the manufacturers are announcing that eventually they will only make electric vehicles. So, for example, General Motors has announced that by 2035 they will only make vehicles with plugs. So that's, you know, that's a trend, and it's based upon some very steep declines in the cost of batteries on a per kilowatt basis, to the point where we're really very close to achieving cost parity for light duty vehicles between EVs and conventional vehicles. We've seen a lot of market growth. That's not market growth we're seeing evenly across the country. It is true that more of the urban and suburban parts of our country are experiencing faster growth, and the growth in rural communities is not as fast right now. But eventually, we will see this adoption and this growth pretty much across the country. And then even prior to that point, because of the increased ranges of these vehicles, we're talking 300 miles and more for battery electrics, and then the plug-in hybrids, which are gas and electric, they have even longer ranges. People are traveling into rural communities, and if vehicles are involved in accidents in a rural community where people are traveling, then emergency responders are going to be faced with that. So it's a very relevant topic, Trina.
Thanks, Sam. And Tom, I know you're here in West Virginia with me, and we are a rural state. What's been your experience so far?
Well, my experience has been that a lot of fire departments know that they're out there, but they don't really have the knowledge or the training to deal with those whenever the incident or emergency occurs. And one of the goals of this program and other programs that initiatives from the National Volunteer Fire Council and the NAFTC is to get the word out on how to properly respond to those. And there's been a lot of media stuff about fires, but it's not just fires. When these vehicles are involved in motor vehicle accidents or partially or totally submerged in water, they can present different hazards. And we want to make sure that the boots on the ground first responders have the knowledge training that they need to effectively handle these incidents. It's just another risk and threat that we have to deal with, and we need to be prepared for it.
Hey, thanks, Tom. We just had Keela Cott from Alaska chat in that they had a Tesla burn for over 3 days up there in semi-rural Alaska. And that kind of leads me into the next question about the differences between conventional and electric vehicles. Tom, you want to take a stab at that?
Yes, in terms of fires, we're used to rolling up on a traditional internal combustion engine vehicle fire with with your pumper with 750 or 1,000 gallons of water and 5 or 10 gallons of foam, and you can knock it out real quick. And unfortunately now, even most of the manufacturers are publishing that in order to properly extinguish an EV fire, you need, on a passenger vehicle, it can be 3,000 to 8,000 gallons of water that has to be applied to the battery. Now, the problem is the battery is underneath the car, and that door skin or that trunk lid or that roof lid has no idea that it's reflecting water that needs to go to the battery cell. So, most fire departments are not accustomed to rolling out with 3,000 to 8,000 gallons of water to a vehicle fire. And I saw one publication that showed a commercial EV required 160,000 gallons to extinguish it over a period of 9 hours. So, we have to understand the differences we're dealing with. Although these are very low frequency events, they are potentially high consequence events. When you look at the data, electric vehicle fires are, there's only 52 total fires in one of the statistics per 100,000, sales, whereas hybrid vehicles now are much higher. They're much higher with the gasoline / electric battery type component. But you have to be prepared for dealing with it. And fire departments, whether you be volunteer, career, rural, suburban, urban, you have to change your response pattern. You have to change your response paradigm and be prepared that should you encounter one of these incidents, you're going to have to, adjust your tactics. You're going to have to be prepared to bring a lot of high quality H2O to the scene. The other thing you have to realize is the scene is not over with when the fire's out. You have to monitor that vehicle while it's being loaded on a wrecker or a flatbed. You want to make sure that there's not the chance of reignition or arcing to the wrecker bed, and just got to change our paradigms.
Hey, thanks, Tom. one of the issues is, can you even identify the electric vehicle? I mean, I know that is the first thing that we talk about when we're talking about first responder response is identification. Maybe each of you can take a shot at this question too. It's like, what are the major differences, in obvious differences that you might notice when you're coming up for a vehicle response to let you know that you're probably or possibly dealing with an EV?
I mean, I guess I can start. Just from I'm not an expert in terms of how an emergency responder would identify, an EV compared to other types of vehicles, but there's no sort of obvious differences between these vehicles in terms of the way they look. People think, oh, are they very different kind of odd looking vehicles? And they're really kind of by design, just kind of regular looking, consumer automobiles, SUVs, pickups, etc. I mean, the full electric vehicles don't have tailpipes, and they have a place where you plug them in. The plug-in hybrids, they would be more deceptive just because they, you have an internal combustion engine, so it has a gas tank, it has a place to insert the nozzle to the tank, and then it also has a plug for the battery piece. And then the full hybrids are just, of course, those just run on regular gasoline, but they have, larger battery packs than a conventional vehicle would be. So no real obvious. I mean, there's some labeling that you see, but no real obvious, at least to me, ways of identifying them just right from the beginning.
And Tom?
The key is the identification, and because of the prevalence of EVs and hybrids out there, there are many response organizations that are treating incidents where every vehicle is assumed to be a hybrid or an EV until they prove that it is not. And that makes a lot of sense in terms of responder safety. The key is you need to know and know what to look for, and do that 360 survey. Walk around, look for any kind of badging that has things that say hybrid, EV. Some of them have a green leaf. There is no uniform badging or labeling on this. And especially in incidents we deal with in the emergency services, that vehicle may have rolled 3 or 4 times on the interstate, and any and all badging is gone. You can't even tell what brand the vehicle is. It's a wadded up piece of metal at the beginning. And I used the incident that happened yesterday on I-81 in Schuylkill County, Pennsylvania. 40 to 50 vehicles involved, and 6 to 8 of them were hybrids or EVs, but they're in a mass of tractor trailers and other vehicles. And you've got to sort that out, and you have to be able to, establish your response priorities, develop the appropriate incident action plan. But the keys are, according to the National Fire Protection Association, is you got to identify it first. And that can be, spotting the battery cells if the car's on its top. It can be from looking at the badging and labeling. It can be from simply the person telling you, hey, it's a hybrid. You never know. The second thing is you got to immobilize it. You got to stop it. You got to make sure the drive wheels or the drive motors aren't going to engage. And lastly, you've got to disable it, which includes de-energizing it and or otherwise neutralizing the power. But the key is that identification, and that's going to come from, training sessions such as this one and the other trainings that are going to be coming up here. Is you got to look and make sure you got to know what you're dealing with. It's just like any other hazard we deal with as first responders.
And can you talk maybe a little bit about the cabling inside? If they happen to see if the car is positioned in such a way that you might see certain components under the hood or, behind the skin of the car.
Certainly, you want to look for if the car is on its top or on its side. You want to look to see, or pop the hood. You want to see, do you see bright orange cabling, which indicates high voltage, or neon blue cabling, which indicates medium voltage, that's coming from a battery. Usually these cables, some of them are very, very thick. They can be like 1 inch in diameter. They almost look like a hose coming off a battery pack on the bottom. But some manufacturers, like some of the foreign manufacturers are, they don't, because there is no mandate on it, are using neon green cabling or bright yellow cabling. And there are people that have done aftermarket conversions and they, give somebody a wrench and a battery and they're going to make changes. You know, but you need to make sure that you want to look for those keys in there. And, you know, if you're walking up on a car and the steam, which typically comes from the radiator, is coming from the floor pans of the car, that's a warning sign. If you smell a strong, fruity or solventy type smell, I love that description. It's a very pungent, acetonish like smell. That's a warning sign. You've got a problem. If you hear popping or cracking or arcing at night, if you see little blue arcs going across where it's grounding to the ground or grounding to a guardrail, that's a problem. You have to understand is we have to be prepared in all types of weather, all types of circumstances to deal with these. But the key is making that initial identification, and things like the group that you're with, Trina, and what Sam's doing with are really trying to push the safety information out there. Nobody wants this to be the enigma of emergency response. We want to make sure that responders are very well prepared. And there's a ton of information out there. Sometimes there's too much. Just about every manufacturer of these, Sam mentioned earlier, there's 83 different types of passenger vehicle models out there. Every one of them has an emergency response guide, but it's not practical to have 83 different emergency response guides here in the cab of your engine and sorting out which one is which. You know, there's some basics that you can do no matter who the manufacturer is, no matter who the vehicle is. And if you understand those key basics, you're going to have a safe response.
So I'm noticing in our chat feature here that just about the time you feel like, oh, I know how to tell these apart, like for me recently, as it was with at Rob Ayton, that the grills are different. They seem to be solid when they're electric vehicle. And sure enough, somebody will come along and the grill will look very similar to just a standard internal combustion engine grill, you know, so just about that. In fact, I was watching another OEM. I have looked at so many, I can't name which one it was, but it was a big OEM who actually bragged about the fact that you couldn't tell the difference between their internal combustion engine and their electric vehicle model that they were offering. So
do not make the presumption that the grill is going to be solid if it's an EV. You have to understand that many EVs have a cooling capacity, some type of cooling system for cooling the battery to prevent things. And it has a coolant radiator just like a car does. They also have, if they have an air conditioner, they have a coolant. There's a, you know, part of the air conditioning system. It would be foolish, and I don't mean that as a disrespect to anyone, to just say it's not going to be an EV if it has a regular looking grill or radiator. When I recently bought a vehicle, I bought a Mitsubishi, and I looked at the EV, and you could not tell the difference between the EV Outlander and the regular Outlander. You could not tell the difference until you went to the back and saw the badging.
So given that, Tom, when we're talking about the basics, I know that we've talked a lot recently about approaching upwind, uphill, and being fully prepared physically to approach the vehicle. Do you want to cover some of that as some of these basics that those fire departments who are saying, okay, we're going to treat every vehicle like an electric vehicle, what they would be doing?
Again, just like with any potential hazardous material incident or any other type of responder incident where you want to ensure responder safety, you want to approach uphill and upwind. Now, again, we're asking you also to do a 360, which means at some point in time, you're going to get downhill and downwind of it. That's why we're also telling people to wear full protective equipment, including SCBA, because until you identify that, there are a lot of potential hazards. These vehicles, again, although they are low frequency incidents, potentially high consequence, they give off, when they're burning, hydrogen fluoride gas, HF, which is extremely toxic, or phosphoryl fluoride, which is another toxic gas. The other issue you have is a lot of fire departments on auto accidents, they wear standard extrication gloves, which are basically, for lack of a better term, a glorified work glove. They might not provide the arcing protection that a firefighter structural firefighter glove, which is much more similar to like a welding glove or something like that. You want to be very careful. You also, when you're looking at stabilization of the vehicle, a lot of times we're taught to start throwing crib blocks underneath it or rescue jacks. That's not what you're going to do with an EV or a hybrid, because you could potentially further impinge on or crush the battery compartment and make your situation much worse. You need to know where to stabilize that vehicle. Again, the other thing you want to make sure is in your disabling of the vehicle, you've got to be very careful. You understand that for totally electric vehicles, the battery is in the floor pan underneath the passenger compartment of the car. You don't want to put responders in peril to disable the vehicle. So reach through one of the windows and use a pike pole and put the car in park. Disable it. Another key thing, which we're not typically trained to do, is get the key fobs away from the car. You don't want the occupant walking up there with the key fobs in their purse or in their hand or thing, because some of these vehicles have auto start. They will, and just because you don't hear the engine running, that does not mean the car has not started the process of initiation. So you want to get those key fobs 25 or more feet away, put them in a bucket somewhere and put them off to the side. You want to make sure that you have to realize that when we talk about de-energizing a standard internal combustion engine, we talk about, pulling the battery cables or even cutting the battery cables. These are cables you do not want to cut. This is a bad thing. 10 minutes to Wapner, bad. Don't do that. They have battery disconnects, and they have, a lot of them have plugs. Now, they may be a cam lock plug where you have to, manipulate a locking device, but then you unplug it and de-energize it. And the de-energization, apologize for that, it has to be between the battery and the drive motor. Simply turning off the car or putting it in park does not necessarily de-energize the vehicle. There may be what's called stranded energy inside the battery, and it can then still go through that. So you want to make sure there's a lot of different things, a lot of different techniques. The National Fire Protection Association has a great program on it. Your program, Trina, has a great program. Sam's program has worked on getting information out, on safety practices. And you may actually be on your phone real quick, Googling the emergency response guide for a Tesla Model T3 or for a Ford Edge or that Ford F-150 Lightning to find out how do you de-energize it and disable it. So you want to be careful. You want to make sure that vehicle is not going to move. There's 100 videos out there. We call it fire porn. I hope that doesn't offend anybody. Vehicles, they're dealing with the incident, and all of a sudden the vehicle's driving away from them. It's on fire, or it's been involved in a wreck, and it's engaged itself and starts driving. Many of these electric vehicles also have these self-driving features, self-park. And you have to understand, all of these systems are highly engineered. They're great systems. They're well designed, but they're designed to operate under normal conditions. And once that vehicle is involved in an accident or involved in a fire, that is an abnormal condition. And just like any other mechanical device, it can malfunction. And that's what we have to be careful of. We don't want a firefighter. I read somewhere that the only documented injuries with true EV fires were a fireman who got run over whenever the car engaged and ran over them. There's been nobody who's been, seriously toxically, exposed or hazard because they were using the proper PPE, but they were like, their foot was ran over, or they were in front of the vehicle and the vehicle engaged and it knocked them down or partially ran over them. So you have to understand, these are considerations that the first responder has to keep in mind. And we're going to be working, the National Volunteer Fire Council, working with the NAFTC and other people. We're going to be working to get more and more information out. the program that I'm with, West Virginia University Fire Service Extension, we're actually developing an operations level course where people will be, we're actually going to set lithium-ion batteries on fire, and we're going to show people the different components of it, and hands-on first responder. The key is training. Know your enemy.
Well, and I think, Tom, as we've talked previously too, there's a lot of thinking on your feet that you're going to have to do. You need some basics, but I'm watching in the chat here, again, getting back to identification. What about some sort of identifier on a car license plate, or the QR codes that may be actually on some vehicles that a firefighter can use to go to that vehicle's emergency response guide? These are things that I know are being discussed, and wonder, what you may be hearing about those kinds of approaches. Either one of you guys, Sam or Tom, if you guys want to talk about that a little bit.
Yeah, I mean, I have not heard a lot of conversation about that, but I'm probably not as much of a position as Tom would be. But I mean, I was noticing those comments as well, and I think one of the values of this kind of a convening and others like it would be these kinds of suggestions and questions and concerns getting raised by the emergency responder community. And then one of the values that Clean Cities can play is to help consolidate and lift those up from the local level up to state and national policymakers, and then the OEMs themselves, because these are the types of things that we need to be looking at to make those early identifications.
And so that the Clean Cities and Department of Energy, it kind of reminds me about what maybe some of the drivers are behind the adoption of these EVs, and whether first responders feel like they have much of a voice in having to deal with the downside of these vehicles. And so I do believe the DOE is interested in this, but if you talk about what some of these other social drivers are and how the first responder community could have a voice in that to make sure that their needs are met.
I agree, and I'm looking at some questions here in the chat. First off, someone said our web-based resources not much use in rural area. For Sue from Spokane, Washington, I can directly relate to that. I'm in West Virginia, where we pipe in sunlight into some places. So I can relate to that. We don't even have cell service. We actually have a national blackout area where you're not even allowed to have a cell phone area because of the Green Bank Observatory. So you are correct. And that's why you need to know the general basics. Going back to another question is, where are the battery cutoff switches at? Typically, they're on the firewall. Somewhere either like directly below what we call the hood curtain, right towards the bottom of the windshield. They're usually very clearly labeled. And again, most of them, they have like a cam lock on it. You pulled it and you are actually pulling out. It's like a fusible link, so that there can't even be cross arcing on it. Another question that I see in the chat there, someone asked about, does extreme cold affect the batteries? Actually, it doesn't. The biggest issue that from reading a lot of, and as Trina will tell you, I've done a lot of research on this stuff as we go through it, and God bless Trina, she's helped out a bunch, is a lot of these vehicles, the battery casing is made out of either metal or an ABS type plastic on the bottom. And driving across unimproved roads and rocks coming up and hitting the battery casing causes damage to the battery cell. And there's been some different studies done about coming up with some kind of safety standard on how much stress the battery cell has to take. But there's been documented incidents of, for example, hitting a deer on the road and the deer going underneath the vehicle, causing damage to it. Actually, but I haven't read anything really where extreme cold causes a problem. I have seen a lot of stuff on driving over unimproved roads. So different things like that.
Tom, there's one question in here too about, general response guides that we might recommend. And, we've talked about the importance of departments developing their own SOGs and SOPs, and that we've been putting together with the NVFC, putting together some tools that they can use to help develop those their own response plans. Do you want to take a few minutes to talk about that?
Yes. I'm a firm believer and a strong believer that first off, you have to do a risk assessment. And Sam pointed out already, and he did an excellent job of articulating it. These vehicles are already here. They are something we have to deal with. This is not something that's going to come 5 years down the road or something we have to deal with, 2 years. We have 2 years to prepare. They're already here. Even though you may not have a dealership in your area, they're transversing your area all the time. So have an SOP and an SOG on it. There was a question in the chat about the flow rate. They're saying that you need to get 500 gallons per minute on the battery. That's on the battery. So you got to get access to the battery. There's different fire departments do different things. As Trina and I will tell you, even in Europe, they're actually picking the vehicle up and putting it in a dumpster and putting it, submerging it in water. There are different places where they're isolating the area and flowing copious amounts of water.
And that's whether you see a flame or not, right, Tom?
Correct. That is whether you see a flame or not, because there's the chance for reignition. And once these batteries start burning, or there's an internal short, you can have what's called thermal runaway. The battery starts heating up internally. You may not have any visible flame at all, but that battery is actually starting the process of combustion. And once these things actually light off, you can get temperatures of 1,800 degrees, which will then ignite anything else you have there, any of the other flammable metals like the magnesium on the drive motors. Some of these cars have titanium shells and cobalt steel, and that 1,800 degrees is going to actually catch that other metal on fire. And you have to understand also at 1,800 degrees, when you're applying water, that 1,800 degrees will cause a separation of the hydrogen and the oxygen in water. Well, old water's H2O, dihydrous monoxide. It will actually, now you have a flammable gas, which is hydrogen, as the people on the Hindenburg know, and oxygen. So you now have something that fuels the fire and a flammable gas. So you've got to put enough water on it that you overcome the thermal imbalance and start a cooling process, as opposed to just trying to abate the fire and actually making it worse. So it can get quite complicated. But have an SOP and an SOG, apply lots of water, make sure you get it on the battery. It doesn't do any good to spray it on the tires. It doesn't do any good to spray it on the doors. It doesn't do any good to fill up the passenger compartment with water. You got to get the water on the battery.
Okay, great. Let's see. So kind of talking about, you've mentioned the flow rate. Let's see. Oh, and let's go back a little bit too. I'm scanning down through these questions here. Let's go back a little bit too and talk about the cutoff points. It's true that the cables will be some sort of a different bright color, generally speaking, unless you're looking at a home done job where you have no idea what you're looking at, but also the connectors themselves may be brightly colored as well. Is that right, Tom?
Sorry, I was on mute there. Yes, the connectors are typically going to be the same color as the cabling. And the other thing is most of the manufacturers have done a really good job of labeling them, saying battery disconnect, fuse here, disconnect here, unplug here. But as Sam will tell you, there is no true national standard on where it's located or how it is. When they first came out, it used to come up, the battery would come up and go down the A post of the car and go into the drive motor compartment. I now seen them come up out, straight up out of the battery pan and go straight into the drive motor with no more than 3 or 4 feet of cabling. There was a question over here in the chat that I wanted to address, says about surfactants. You have to understand is you're not dealing with a hydrocarbon fuel that's burning. You're dealing with lithium ion reacting with cobalt, and you're dealing with a chemical reaction fire. The hydrogen fluoride gas that's coming off it comes off from the creation of hydrofluoric acid in the battery through the through the electrolysis process of storing and energizing. So you want to make sure a foam is not going to make any big difference, because you're, number one, remember there's three components of foam: the concentrate, the water, and air. And at 1800 degrees, your bubbles that make foam are going to pop like pop, 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 pop. So your foam is not going to have any real efficacy. It's going to be too hot for that. So foam is not going to work. You've got to just use water, lots and lots of water. Now you can do things to break down the viscosity of the water. I've seen people try that. Use like a 1% Class A type foam to break down the viscosity of the water so that the water actually stays where it's at. But you still got to get the water on the battery. That's the important part. A lot of people waste a lot of water, and if it's running down the berm, and not getting on the battery, that's not a good thing. And I know that Sam's group and the NAFTC has heard the discussion, about consistent labeling and consistent this. It's the federal government has a somewhat refractory period in regulation, and you have to understand it'd be like them telling how Chevy has to label the Impala. Has to be the same that Ford labels the Fusion, which is the same that Hyundai has to label the Sonata. They have brand and they have branding. And the other thing is you have some control. Look at how long it took to get safety glass, laminated glass and tempered glass implemented in the United States, or seat belts, or Ralph Nader's bolt on a door. It took years. These discussions are not falling on deaf ears. And, I commend Sam's organization, because as they're pushing this initiative, they didn't ignore safety, and they're not saying, hey, everybody needs to have an EV and we don't care about safety. They were one of the first to start talking about safety, that people have to be prepared for it. Just as Trina's organization is with that. But we have a responsibility as a response community to be prepared. We can't sit there and let Sam's organization or Trina's organization dictate how we handle. We have to be prepared to respond today. And I'll get off my soapbox now and let Trina talk.
Well, and I'd like to ask, because of your hazardous materials background too, I'm seeing a number of questions that may be related to, is there any possibility for hazardous material runoff as you're dousing the battery to keep it cool? Are there any concerns about runoff into, nearby streams with all these thousands of gallons of water? And I'm not sure if I've actually heard much talk about that particular issue. Have either of you heard that?
I have. The solution to pollution is dilution. And when you're flowing, 3,000 to 8,000 gallons of water, the amount of hazardous materials in runoff is going to be negligible. No different. It's actually, in my opinion, it's going to be less than you're going to have with an internal combustion vehicle. Because keep in mind, you got to look at capacities. An internal combustion vehicle typically has an 11 to 19 gallon fuel cell. If it's a pickup truck, it's got a 35 to 50 gallon fuel cell. You've got 5 to 8 quarts of motor oil in it. You have up to 2 to 3 gallons of ethylene or propylene glycol in the radiator. Then you've got AFFF transmission transmission fluid. Then you've got brake fluid. So you've got all these other hazards, and as we all know, antifreeze, propylene glycol or ethylene glycol is a land banned substance. It's any of it on the ground is a problem. But so I think the hazards from a hazardous materials perspective are a lot less. But you have to realize the two toxic compounds, the hydrogen fluoride, HF, or the phosphoryl fluoride, are real players. They don't mess around. 40 to 60 parts per million are a bad day. That's why we've got to wear our full PPE. And I know people, blah, 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 got to put our air pack on. Yes, put your air pack on. And if you do become exposed, There's a difference between exposure and contamination, but if you breathe these things in, these fumes in, you need to treat it as a chemical exposure, not as a typical smoke inhalation. You have to treat it as a legitimate hazardous materials exposure. And that's where you need to look at NFPA 473 or other protocols and guidance. The old method for smoke inhalation of high flow O2 and large bore IVs to make sure that we get fresh air into them may actually be a catalyst to driving the toxins further into the bloodstream. So you don't necessarily, you want to get with your medical command and your medical protocol and treat those as true chemical exposures. But you just got to be careful. You want to make sure that you're, much of it can be neutralized. You can neutralize hydrofluoric acid with baking soda. You could technically neutralize the entire battery cell component with about 6 pounds of sodium bicarbonate, good old Arm & Hammer baking soda. And you raise the pH up to 6.1, 6.8 and not really do anything. But that's a little more specialist hazardous materials type stuff. But I would not be concerned with the runoff on an AV fire as much as I would be on an internal combustion fire. You have a
or hybrid electric vehicle.
Yeah,
you'd have both.
Yeah, you would not. You got to realize with an internal combustion vehicle, that gasoline, everything migrating down the water stream has the ability to light off and flash back. Your fire is on an EV is going to be confined to the vehicle. You're not going to have petrochemicals rolling down the ditch line that you got to worry about igniting or catching off.
So let's talk too a little bit about other responders who show up at the scene. And I'm talking about your tow operators or where the vehicle goes to the salvage yard. Those are also responders that, we've put together some training at the NAFTC to help address. But Tom, where does the first responders' responsibility lie in working with our, second responder community?
Well, you have a responsibility. For example, number one, all of the published recommendations and every ERG I've ever looked at for one of these EVs states that the vehicle needs to be towed with a flatbed. The reason why you don't use a conventional wrecker or wheel lift is that you can kink the body compartment and further compromise the battery and generate a potential for a secondary fire or a reignition. So you want to tow it with a flatbed. Different tow operators I've spoken to talk about using a rubber mat on the flatbed so that there's no arcing between the battery pan and the aluminum bed of the wrecker. So they put a rubber mat underneath it. You want to follow it. You want to follow up and tell them, hey, if you go back to the yard, and there's any wisps of smoke or any arcing or popping or cracking, you call us. I want to back up a minute when we talked about other responders. If one of these vehicles is involved in an auto accident, we have this all the time, and you have patient entrapment or patients still in the vehicle, they may not be entrapped, but they just are not able to ambulate or motivate. You may want to just do grab and goes and get them out of the vehicle because they are sitting on top of that battery compartment and you can have a problem. That is not the time to, once you start seeing smoke and flame, that's not the time to be worried about, oops, now we got to get them out of the car. So you want to make sure that your EMS people and everyone else are trained and aware. You also, a lot of times, well, we got to get in the car and we got to get the registration and the insurance. If there's ways to do that safely. Make sure whoever's doing it is wearing the proper PPE and doesn't spend as much time in the passenger compartment any more than they have to. With regard to the tow operators should be advised if the battery cell is impinged on or otherwise compromised, tell them to park it away from everything in their yard. For many, that's a challenge. But don't park it right up next to a building. Don't park it. Some insurance companies, I had a very spirited discussion with an insurance company insisting on inside storage. And I was like, and the guy, great guy. And I finally said, Gene, hey, look, you're already paying for the vehicle. Do you want to pay for the building too? you know, and he said, hey, Tom, that's a good point. They may not, they even, you'd be surprised how many people do not understand the issues that we're dealing with. The reason I was talking to this insurance company was one of their adjusters, while he was out playing around in the car and climbing through the car, he got exposed. He got overcome, and they went down there, and there was a strong fruity solvency smell and everything else. And he became short of breath, and he's crawling through the car 3 days later. So you want to make sure everybody knows. I know of at least 2 fire departments that have little quick tip sheets for tow operators that they just pull out. Here you go. You're taking this car. Here's what you need to know. If anything happens, give us a call. Is that going to work for everyone? No. But you have to find out what works for you and as part of your SOP and SOG. But you have to understand, with EV calls, the call may not be over with when the call's over with. Trina, as you know, when we were talking about this, you tried to get a hold of the gentleman where they went back to the wrecker yard 5 times in 3 days. And, because the car kept reigniting and lighting off. And
so do you want to talk a little bit too about the value of thermal imaging at the scene and post response?
Oh yeah, I mean, this webinar could be 4 days long. Use your tick camera out. You'll notice when we did some test burns of batteries, even with little AA cells, we noticed temperatures of 11 to 1200 degrees with lithium ion batteries. So I see Sam sitting there shaking his head. Yeah, these things generate a lot of heat. They generate a lot of heat quick. So use your thermal imaging, and you're going to have to. I'm an old guy. I'm 58 years old. Sit down. You want to sit down, and you're going to have to get underneath the car, and you're going to have to look along that battery with that tick, and you're going to have to reassess, monitor. You want to start with thermal runaway. The temperatures typically in the battery cell on a normal vehicle are around 90 to 100 degrees. When you start putting the thermal imaging down there and you start seeing hot spots of 250, 310, 400, you may be experiencing thermal runaway in that battery. Not always, but you have to understand is when that battery's in use, it generates heat and it has some type of cooling system in it. Many of them are fluid cooled. The fluids vary between manufacturer and manufacturer, different technologies, but you want to be monitoring that. You want to be checking that with the thermal imaging. And then as it's being loaded up on the wrecker, sit right down there as the car's coming. When it breaks the angle of approach up on the flatbed, be putting that tick in there. Get a look at it. Want to make sure that that you're prepared. That's the nice thing about ticks is they have so many different applications well beyond the structural fire realm.
So what I'd like to do too is in the few moments that we have remaining here, talk about maybe a little bit more where some of these resources are. I'm seeing some great things come in on the Q&A, the chat, like the Energy Security Agency can provide risk assessment and guidance 24/7 for EV and hybrid vehicle incidents, and there's a link in the chat to that information. And I know we're working with the NVFC to post a general EV awareness training that's about a 1-hour webinar. It features our friend Tom Miller, and we'll provide a toolkit that will go along with it so that you can start building your own awareness and pulling together some of these basics for your SOP, SOG. But also, Sam, I wouldn't mind asking you if you can talk a little bit about the role that Clean Cities has played and the partner that they could be in helping to provide some of this training or access some training. And you're on mute, so you'll have to unmute first.
Thanks for the reminder. I would not have remembered that. Well, actually, first of all, I just wanted to say that this is, this is an incredibly valuable experience for me personally, just to, be part of this webinar and to hear the comments, especially from Tom, and then even the chat. I mean, there's a lot of very knowledgeable people with valuable
Oh, Sam, you're breaking up a little bit.
information.
Sam, you may have to turn off your video to see if we can just get your verbal response, because you've frozen. And I may have to pitch it over to Matt to see if there are any other technical assistance items that he can provide. Sam. Oh dear, I feel like we've lost Sam. Well, I can say if, in my own experience with Clean Cities, I had been contacted by a fire. Oh, there you are. Are you back?
Yeah.
Okay, go ahead.
Can you hear me
now?
Go
ahead. Yes, yes.
Okay. Well, I was just saying how much I appreciate being part of this. It's just been a great learning experience for me personally to hear, especially from Tom and then a number of the comments in the chat. I guess from a Clean Cities perspective, I mean, this is, I just talk a little bit about what that is. First of all, it's a 29-year-old federal initiative. It is not really, the name is not maybe not.
Oh dear, Sam, you're breaking up again. Oh, Sam. Well, maybe if I start with my story. Okay, are you back?
I think so.
Okay.
I can take one more shot at it, Trina.
Okay, all right.
I mean, I guess the bottom line, I mean, I think there's a lot that Clean Cities can do locally in terms of bringing information programs, that information conduit. There's been a lot of Clean Cities that have done, that have sponsored and partnered with emergency responder organizations like NFPA and others to present programs. And so the best way to find your local Clean Cities Coalition is just by searching under Clean Cities. Just go onto your web browser and type in Clean Cities or DOE Clean Cities. Yeah, I think Trina just put that into the chat. Not all states have a Clean Cities Coalition. So in those cases, you can reach directly to the national program people who should be able to help you. But, partner with them and then work with them. They could be a conduit to bring expert resources like Tom and others, into the picture to help provide that education, and also the connections with the OEMs if that's what you're looking for as well.
And so, for example, the Clean Cities are likely the folks who are going to understand how many EV sales are happening in your region, because they actually have access to that sales data through the Department of Energy. That's one of the benefits of being a Clean Cities. So when you're trying to assess what's happening in your region, your area, your Clean Cities coordinator may actually have that data that they could share with you. I know I'm sharing mine. And they also have funding to provide training. And I've partnered with Clean Cities to assist a fire department that expanded more regionally to other fire departments for a broader webinar on, how to handle, it was an EV awareness training. And again, the expense for that was picked up by the Clean Cities Coalition. So the fire department, which is a volunteer fire department, has no money anyway, was able to not have to spend that kind of money to seek that kind of training. So I think if you are able to find a Clean Cities in your area, they could be a very valuable asset in your stakeholder community in helping you to address this kind of EV revolution that's happening.
Yeah,
and that sales data can be the basis of your risk assessment.
Yes.
For the fire department.
Yes.
For your emergency, Sam's information that he provides you will show you what your true threat risk profile is.
Yeah, and also as we get more into the medium and heavy duty side with electric vehicles, Tom was speaking before about the increased hazard there because you have larger battery packs and so forth, more complicated situation. That's also where a lot of times Clean Cities can have information on who is adopting electric vehicles among those types of fleets. We're going to see this onslaught of electric school buses going into all kinds of communities. There's federal funding to back this up, and also with transit, electric battery transit buses, et cetera. We've got terminal tractors at various logistics centers that are being, we're seeing more of the fully electric versions of those, et cetera. So yeah, I'd recommend partnering with with Clean Cities. The funding piece, oftentimes that's the case. Sometimes, if not, there's ways of partnering with Clean Cities to go after that funding if it's not readily available. So absolutely, I'd recommend reaching out to your Clean Cities and partnering with them.
Sam brings up a good point, and I want to touch on it real quickly, Trina.
Okay.
Is you have to understand it's not just the vehicles on the roadway. There's huge amounts of lithium-ion battery, forklifts, man lifts, other pieces of construction equipment out there available, and they are vehicles. And so you may not just encounter these types of things on the road. You may encounter them in an industrial site, may encounter them in a warehouse. There's a big shift now from propane powered forklifts and things like that to, lithium ion type equipment. So, the spectrum of where you may encounter this is very broad now.
Thanks. So what I'd kind of like to do right now is a quick, and I do have one question here, wondering if in addition to the recording, will the chat history be available, which I think could be useful because there are a lot of great links in here. And so I've just made the NVFC coordinator aware of that, and hopefully he's going to be able to capture that in his Zoom download. But I wanted to do a kind of quick recap of the things that I heard that are kind of comprise the basics that you would want to start building around. And Tom, you by all means correct me where I get off course. But first and foremost is identify, then immobilize and de-energize, right? And you're approaching the vehicle from upwind, uphill, in full PPE with SCBA and your the special gloves that I'm having.
Structural firefighting gloves.
Thank you. The structural firefighting
and
gloves.
It's not necessarily de-energize, it's disable.
Disable.
Which
yes.
includes part of de-energization, but you also want to make sure that it's not going to re-engage. That includes getting rid of the keys, getting rid of that other stuff.
Right. And then you want to have lots of water on hand. Water is your best friend at these scenes because your goal is to cool the battery. I mean, you put out flames, but you keep throwing water at it. And we're talking 5,000 to 8,000 gallons per vehicle, per electric vehicle, or vehicle that has an electrical component. And then you do have a duty to inform your tow operators and salvage yards that they're dealing with an electric vehicle and they need to take appropriate actions there. And that there's that follow-up incident response using things like your thermal imaging camera. So I think that kind of encapsulates the basics that we're trying to get out there in our EV awareness to get you started. And Tom, is there anything else that you would add in that kind of recap?
Again, develop your SOPs and SOGs and make sure that you reach out to the Clean Cities Coalition and those other partners that we've talked about here, and just keep paying attention to the National Volunteer Fire Council. We're working on trying to get some more information out there with a webinar that we're doing, and we're building a toolkit of vetted resources that you as the first responder can use as part of training programs and as part of increasing your awareness level with regard to these types of incidents.
And I've just opened the Q&A component, and we've covered a lot of this sort of thing, a lot of the questions that are in here, but things like, are there slide presentations on electric vehicles that you can use in training? Well, those are going to be among that toolkit. There are links to various types of presentations that you may be able to use as you're doing your training and making your department aware. Let's see. And among that training is a set of videos that focus on Teslas. And, Tesla is the dominant EV in the market right now. But again, you got to remember EVs represent about 3% of car sales in 2021, and your hybrid electric vehicles are 5%. And your vehicle fires in hybrid electric vehicles exceeds even vehicle fires in gasoline vehicles. So don't lose sight of the importance and the relevance of EVs. And the charging station, we could do another whole session on what to do at a charging station. But the one tip I will give you that I've heard over and over again is make sure that there are ballards. Is that what they're called? The big concrete poles around bollards around wherever that recharging facility is so that nothing can hit it. I mean, that's the first thing, but there are a bunch of other tips, and that's for another show, as it were. But that's a good point that you may be dealing with that as well.
Many EV fires are directly related to improperly installed charging stations. You know, Billy Bob goes out here and buys a charging station, you know, and doesn't have it properly installed, and you know, it's just like anything else that's poorly wired. It's gonna create a problem. So there's a lot of war stories out there about you know, EV fire. The vehicle wasn't the problem; it was the charging station.
Right. And so I think we can talk with the NVFC about, you know, the possibility of looking into that more deeply, especially as it's related to structures. So I know we're at the 4 o'clock hour, and that is all the time that we have for now. I do want to thank our panelists, Tom Miller and Sam Spofforth, and everyone else who's joined us live. We've had quite an active discussion going on, and I think we've all learned quite a bit here. So I want to thank the National Volunteer Fire Council for organizing today's discussion. The NVFC is the leading nonprofit membership association representing the interests of volunteer fire, EMS, and rescue services. They provide resources, training, advocacy, and programs to help the volunteer emergency services thrive. You can learn more about the NVFC and what they do, as well as access resources at www.nvfc.org. And if you're not a member, it's a good organization to look into to join. It's just $21 a year and comes with a variety of benefits, such as free training in the NVFC virtual classroom and access to Volunteer Voices member community and much more. Again, you can learn more at www.nvfc.org/join. I also want to acknowledge that this discussion was made possible thanks to a grant from General Motors. Learn more about their push for electrification by clicking on the link in the video description. We'll also include in this video's description, when the video is posted, the links to the National Renewable Energy Laboratory, the National Alternative Fuels Training Consortium at the West Virginia University Energy Institute, and vehicle response resources that will be housed at the NVFC website. If we didn't answer your question, please mail the NVFC's Communication Director, Matthew Odom, at matthew@nvfc.org. Again, thank you and have a good afternoon.